Welcome back to another Algebra 2 lesson. Last time we talked about how to identify linear, quadratic, and exponential models or functions. Today we're going to look at the models on a graph and use that to interpret information in context. So if I was going to preheat my oven before using it to bake, and one of my students created this graph to predict the final temperature after X minutes. So looking at my axes labels, that's going to give me the most information here. Time is in minutes. And then I've got temperature in degrees Fahrenheit. And then this is a linear graph, so that tells me I'm going to have a constant rate of change or increase because my slope is positive here. So again, what does the slope of this line represent? So slope is your change in y over your change in x. So a change in y here would mean a change in temperature or degrees Fahrenheit, and that is an increase. So we're looking at the increase in degrees Fahrenheit, and then my change in x, well, that is time in minutes. So this is the change or increase in degrees Fahrenheit per minute. So when you're answering a question like that, you want to be super specific, because if all you're saying is the change in temperature, well, that would be like if I didn't have the graph. We know the graph, we know it's a positive slope, we know it's increasing, we know our units of measure for the temperature and the time, so you want to be as specific as possible. So what does the y-intercept of the graph represent? Well, let's think about that. This is the coordinates 0, 70. So what do x and what do y mean in this scenario? Well, I know that x is my time, 0, and 70 is my temperature, 70. So if I think about when I started recording the temperatures, that would be probably when I turned on the oven. So at time 0, that means it's the starting temp of my oven, or probably room temperature too, because it incubates or acclimates to the surrounding area. And we know that it is or was 70 degrees. What would an x-intercept represent? Now, if I had one, which I don't have here, but that would mean I'm crossing where y is 0. So if y is 0, that means that the temperature is 0. So that would tell me the time when the temperature of the oven was 0 degrees. Now, that's not likely to happen, which is why our graph is only in the first quadrant, because in this context, it doesn't make sense to show this line going all the way backwards and crossing the x-axis. What is the meaning of the y value when x is equal to 2? Well, if I look right here at that table, or excuse me, my graph, I've got 2, 140. So the meaning of the y value when x equals 2, well, that tells me the temperature of the oven after 2 minutes, or 2 minutes after I turn it on. And we know that to be 140 degrees by looking at our graph. What's the meaning of the x value when y is 210? So here at this point, 210, the meaning of the x value there is the time when the oven reaches 210 degrees, or how long it takes it to get to 210 degrees. And we know it to be 4 minutes by looking at it on the graph. Okay, this next one is going to be a quadratic graph. Zach kicks a football, and we're looking at the height of the football in meters. That is labeled here on our y-axis after time t seconds. So that's labeled here as well. So it looks like we're starting at a height of 0. We go up to a maximum or a vertex, and then we come back down to 0. So after how many seconds does the football hit the ground? Well, the height of the ground would be 0. So the time it takes to get there would be how long it takes me to get back to 0. And we know that that is 4 seconds for this particular graph. Find the interval for which the ball's height is decreasing. So that means where are we going back toward the ground? If I was walking on this graph, first I'm walking uphill, then I'm walking downhill. The interval where you're walking downhill is where you're decreasing. And you use the x values to describe your location there because we're moving from left to right. So starting at 2 and until 4, my graph is decreasing, the height of the ball is decreasing. And then lastly, how many seconds have gone by when the football is at its highest point? Well, that's going to be the vertex of your parabola here. So how many seconds have gone by? Well, that would be the x value because our time is x here. So that would be 2 seconds. And we could also use this data to say what the maximum height of the ball would be because it labels it here. That maximum height at that time is 19.6 meters. So there is more that we could interpret and say about this graph, but we are going to move on to Jacob purchasing a used car. And this exponential graph is predicting the value of the car after X years. So looking at our labels, we've got time in years for the X and our value of the car in dollars for the Y. So what does the y-intercept of this graph represent? Well, if I'm thinking about those coordinates, there's my y-intercept. This is 0, 15,000. So what does the y-intercept mean? Well, that means at time 0, the value of the car is $15,000. And if we're talking about when Jacob purchased this car, time 0 would probably mean when he bought the car. So the purchase price of the car was $15,000 because he's not going to start measuring the value until after he buys it. Why does this model not have an x-intercept? Well, an x-intercept would be all the way down here when the value of the car would be 0. So will the car's value ever be 0? Probably not. There will probably always be some part on the car that you could sell, whether it's metal, tires, etc. So the car value will never reach exactly 0. How many years from now will the car be worth $4,000? Well, that means I'm going to look where is my y value equal to 4,000, and that is here at 4,000. So that time is going to be my x coordinate in years. That is going to be 8 years after he purchases the car. What would a point on the graph with a negative x value represent? So if I'm going beyond to the left of this quadrant where my graph is shown, so that would be meaning that my x coordinates are negative, so my time is negative in reference to when the car was purchased. So a point beyond this would tell me the value of the car before Jacob purchased it because he did purchase a used car. Okay, that is it for graphs. We are going to switch gears a little bit to interpreting some functions. The first two are exponential. So this is my exponential function, and it's representing a change in quantity over t years. So that's telling me that this t represents years. What does the constant 9.65 reveal about the rate of change? So this tells me my initial value, which we'll get into later on, but this tells me something about my rate of change. So what we're going to do is take that constant 0.965 and subtract 1 from it. And when I do that, I get negative 0.035. So first of all, because it's negative, that tells me that this function is decaying instead of growing. And then to get the rate of decay, I'm going to take this decimal and turn it into a percent. You move it to the right too. So that is 3.5% over what period of time? Well, I'm going to look at what it told me my exponent represented, and that was t years. So this is every year. And that is how you can interpret exponential functions if you don't know anything else about the context or the values. Let's look at the next one. I've got another function which is representing a quantity over t hours. So this time t is hours, not years. What does the constant 1.35 reveal about the rate of change? So again, I'm going to take that constant 1.35 and subtract 1 from it. This time I get positive 0.35. So because it's positive, that tells me that we are now growing instead of decaying. Exponentially growing at a rate of, I want to convert this decimal to a percent. I'm going to move it over twice, so that is 35%. I got to look back at what it told me t represented, and that's in hours, so every hour. Okay, one final problem, which you should be able to do pretty easily, but you do have some stuff like this on your homework. I want to make sure you understand how to set it up. Members of a lacrosse team raised this amount of money to go to a tournament. They rented a bus for this amount, and they budgeted this much per player for medals. So we want to write and solve an equation that can be used to determine X, the number of players the team can bring for the tournament. Well, this is a linear relationship, mx plus b. We have our fixed cost of, the bus amount. We have our cost per player, our slope. And so essentially what we are solving here is y equals, we've got 3775x plus the cost of renting the bus. If this is my y value, what x value goes with it? So I'm going to substitute $1,672.50 in for y. And I'm going to solve this for x. So first I'm going to subtract, and that leaves me with $604. So then after I do my division, what do you know? It works out quite perfectly. It is exactly 16. So we can take 16 members to the tournament. So hopefully that's a problem that's very accessible for you, but if it's not, think back to y equals mx plus b form, what you know, what you're looking for. Okay, I hope you enjoyed this, and we are going to be continuing with linear models next time.